So when is this relationship between logarithms and exponential functions useful? So logarithms and exponential functions are inverses of each other, which mean one undoes the other. And generally, the thing that's going to allow us to undo or to get x by itself or solve or whatever you want to call it is that power rule that we talked about. So up here is an exponential function, and I can tell because it has a variable in the exponent. I need to get that x by itself, just like most often we do in math. Okay, so I'm trying to get this x by itself in order to solve. Here, I need to get this 10 to the x over 3 by itself first before I can proceed any further. So I'm going to want to divide both sides by 4. So I get 10 to the x over 3 is equal to 3. Okay. Then, this x here, I need to get rid of this, I need to get it out of the exponent, right? It needs to come out of its position. And the thing that undoes an exponent is a logarithm. They're inverses of each other, just like multiplication and division undo each other. Logarithms undo exponents because here's what happens. We're going to rewrite this as a logarithm. So thinking about if I want to rewrite it as a logarithm, I know I have my base, I'm going to need my argument, and I'm going to need it to be equal to something. And I'm going to use my wraparound to figure out which order they go in. So it would be log base 10 of 3 is equal to x over 3. Now we got really lucky because look at this, log base 10. Log base 10 is our common log, which means that log of 3 I can just put in the calculator. Okay. But sometimes read the instructions because your problem will either ask for your answer in terms of logs or as a decimal. So let's do both so that you are able to do whatever's asked of you. So log of 3. So if I'm going to do logarithm first, I don't want to plug it into the calculator yet. I just want to get the x by itself. And here in this equation, that's pretty simple. I just want to undo this divided by 3, which I know the inverse is multiplying by 3. So I have 3 log of 3 equals x. Okay? So if I was asked to leave this in terms of logarithms, this would be my answer. Or because it was a base 10, it was the common log, I can plug this into the calculator. And when I do, I get an answer of 1.431. And notice again, we have it rounded to 3 decimal places. On the AP Calculus exam, we're going to want to round everything to 3 decimal places. Okay? So get it all the way down here. And so this would be your log form. This would be your decimal. Let's try another one. In this one, I am going to look for my base because I know this is an exponential, right? I've got a variable in the exponent. So I want this e to be by itself so that I can use a log to undo that exponent. So I need to move this 30, undo this 30, which means I'm going to divide by 30 because it's currently being multiplied. And I get 0.1 is equal to e to the negative 0.6t. Okay. If it helps you, which it helps me when I'm switching, this is backwards of how we've been using my wraparound. So if you like to use that trick, I'm going to switch it around because we know that if both sides are equal to each other, I can write them either way. Okay. And now I'm going to try to put this into log form because all that's left is a base with an exponent. So now I can try to undo that exponent. So I know that my formatting is going to be log. I'm going to have a base, an argument, and it's going to be equal to something. And use your wraparound. And so I get log base e of 0.1 is equal to negative 0.6t. Now we got lucky again because we have log of e. And we know from a little bit earlier that that's another common log that we call the natural log. So the natural log, I'm going to rewrite this as the ln of 0.1, or the natural log, so this whole thing became natural log, of my 0.1 equals negative 0.6t. I'm going to find it both as a logarithmic answer and as a decimal. So to do my logarithmic, I want to keep this for now and just divide by negative 0.6, divide by negative 0.6. So if you were asked to write your answer in logarithm form, you would stop here. This is as far as we can go, okay? Grammatically speaking, we should probably put the negative out in the front. Now, I also, because it's ln, I could plug this into the calculator, and I would end up getting 0.384 is equal to t. And again, we used 3 decimal places, rounding to the nearest thousandth, because that's what we're going to be expected to do on the AP Calculus test. We want our answers to be precise.